Alright, in this video, I'm going to be solving the equation x to the power of 3 minus x squared is equal to 100. So, my only variables in this equation is x, so this is what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation down here so I have a little more solving space. So I have x to the power of 3 minus x squared is equal to 100. And now I'm going to subtract 100 on both sides as my first step. So now I get x to the power of 3 minus x squared minus 100 is equal to 0. From here, I'm going to rewrite x squared, or negative x squared, as negative 5x squared plus 4x squared. And next, I'm going to write 20x minus 20x, and then I have this minus 100 is equal to 0. So the reason I did this is because 5 times 4 is equal to 20, and we want to make this factorable, so we need to have two terms that, when added, make negative 1, and when multiplied, make 20. So now from here, I can reorder this and make this equal to x to the power of 3 plus 4x squared plus 20x minus 5x squared minus 20x minus 100 equals 0. So now I can factor this much simpler. So from x to the power of 3 plus 4x squared plus 20x, I can factor out x, so I get x times x squared plus 4x plus 20. And now from negative 5x squared minus 20x minus 100, I can factor out negative 5, so I get negative 5 times x squared plus 4x plus 20, which is equal to 0. And now notice how both of these terms have x squared plus 4x plus 20 in them. So now from here, if I factor out x squared plus 4x plus 20, I get x squared plus 4x plus 20 times x minus 5 is equal to 0. And this gives me two equations. I get x squared plus 4x plus 20 is equal to 0, and x minus 5 is equal to 0. So I'm going to first start by solving x minus 5 equals 0. So to solve this, all I have to do is add 5 on both sides, and I get x is equal to 5. Now for x squared plus 4x plus 20 equals 0, I can use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, in this case, a is 1, b is 4, and c is 20. So I can just plug these in to this formula. So now, I get x is equal to negative b, and b is 4, so negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And now this is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 20, which is 80, over 2 times 1, which is 2. And now this is equal to negative 4 plus or minus the square root of negative 64 over 2. And from here, notice how we have the square root of a negative number. And most people would think that this is not possible to do, but what we can do is rewrite this as negative 4 plus or minus the square root of 64 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace the square root of negative 1 with I get x is equal to negative 4 plus or minus the square root of 64 I over 2. And the square root of 64 is equal to 8. So I get x is equal to negative 4 plus or minus 8i over 2. Negative 4 divided by 2 is negative 2, and 8 divided by 2 is 4. So these are two other solutions. Now, my three solutions to this problem are x equals 5, x is equal to negative 2 minus 4i, and x is equal to negative 2 plus 4i. So these are my three solutions to this problem. Alright, so in this equation, I'm going to be solving 3 to the power of x is equal to x to the power of 9. So, to solve this, what I'm first going to do is take the power of 1 over 9x on both sides. So I get 3 to the power of x to the power of 1 over 9x is equal to x to the power of 9 to the power of 1 over 9x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 1 over 9x is going to equal 3 to the power of x times 1 over 9x. And this is going to equal x to the power of 9 times 1 over 9x. Now x and x in the denominator here cancel out. So I get 3 to the power of 1 over 9 is equal to x to the power of 9 and 9 cancel out, 1 over x. Now, one over 9 is the same thing as 3 over 27. So now I can rewrite this as 3 to the power of 3 to the power of 1 over 27 is equal to x to the power of 1 over x. And 3 to the power of 3, well, that's equal to 27. So I get 27 to the power of 1 over 27 is equal to x to the power of 1 over x. And notice how these two are in the same form. A number to the power of 1 over that same number, meaning x is equal to 27. So now to check, I can plug this into my equation. 3 to the power of x is equal to x to the power of 9. X is equal to 27, so I get 3 to the power of 27 is equal to 27 to the power of 9. And 27 is the same thing as 3 to the power of 3. So I get 3 to the power of 27 is equal to 3 to the power of 3 to the power of 9, which is equal to 3 to the power of 27 is equal to 3 to the power of 3 times 9. And 3 times 9 is 27, so I get 3 to the power of 27 is equal to 3 to the power of 27. And this is right, so my solution over here is right as well.